Hi everyone, how you doing? Nice to see all of you. Seriously, B-Sides Prague First Edition, amazing, amazing work. Thank you so much, Martin, Cooper, organization team, everybody. Thank you so much. And thank you all for joining me today. All right, let's see if the clicker works. Does it work? It doesn't work. No, it works. Here's my afro. So it works. Hi, my name is Abdullah Joseph. I've been working in security for a bit. Currently, I work consulting ad tech to enhance their application and cryptography practices. I'm actually going to put a timer so I don't go over time. Nice. All right, so let's do it. So today, I have a talk to describe a few things that related to the mobile ad industry. I've been working on it for about 10 years now, something like this. I worked as a developer, so forward engineer, and I've worked as a security researcher, and I worked as a team lead hiring other people in it. So I jumped about 4 companies through it. So I've seen a few publishers, advertisers, advertisement networks, attribution partners, all terms that we're going to introduce today and see how it goes. But there's a quick disclaimer in here. And this is a disclaimer I do most in every talk. I like security research. I like the stuff that I'm doing. I'm very blessed that I was able to reach the position where I can talk to beautiful people like you and publish wonderful work. But there's a disclaimer. As an offensive person, as a person who's doing offensive security research, I don't want to kick anybody in the balls. There will be some slides in here where I'm talking about some bad practices for some people, and this video will be live. So, disclaimer, this is not about me kicking anybody in the balls. This is not about me trying to make anybody tell them that they're doing a bad job or something like that. That's weak and childish. The responsibility that I'm trying to do here is educate and have fun in the process, and ideally not try to improve the status quo, push the envelope a little bit further, pay it forward, and not try to make things worse for everybody. The worst outcome for me in this presentation would be that someone actually gets fired or somebody gets really annoyed or get yelled at. That's not something that I would like to do. So let's talk about some goals for today. I don't think anybody in here is so familiar with the mobile ad space. Is there some, does the volume go up a little bit too much when I'm talking? Or is it good? Okay, I'll stop. So I have a couple of goals today. I want to introduce you a little bit to the mobile ad space, and I would like to show you some really weird exhibits that I found through my career. And we're going to go through a couple of history of some published security work that people have taken very serious and have changed and evolved, and some stuff that I've researched. And I do work in the industry. I work in the private sector. I work currently for one employer, but I do consult for others. So I'm not going to name any names in this presentation, and that's not a question. That's not something that you're going to get out of me. But we're going to see some of their attacks. We're going to see some code snippets, and hopefully we'll all enjoy some really weird stuff in the offensive scene. So let's talk about some players. So we have 4, mostly, the ones that we actually care about. The others are a little bit secondary. So we have publishers and advertisers, okay? So a publisher is a person who creates the mobile apps. It's a person like Snapchat, Facebook, Instagram, Google to an extent, but we're talking about mobile apps. So in here, we have those publishers who have those beautiful interstitial video ads or an ad bar or something that what you would call an ad inventory. And those are apps that have ad space. You actually can advertise through them. And we have the advertisers who we're going to give an example in a minute, but they're basically companies that are trying to advertise their brands. They hope that they can get on the publisher's ad space, ad inventory. So for example, if I created a game, I would want everybody on TikTok to know that I have a cool game. I want TikTok to display the ad every single minute. And in that case, I am the advertiser, the TikTok is the publisher. Now let's talk about how to make life easier. This is an advertisement network. If I, as an app developer, go specifically to TikTok, to Facebook, to Instagram, and those are just big names. Those are actually the self-attributing networks, term we're not going to discuss too deeply. It's hard to go to every single app and try to say, oh, please advertise my product. It's really cool. A much easier way would be for you to go to an advertisement network who are brokers, and they will connect the 2 dots. And they do everything together in a very high-speed market with a 6-second number, which is the magic number. And that magic number means that when the user clicks on something and then installs it, everything needs to be attributed through across every partner. They have this technology. It's really interesting. And there's a lot of advertisement networks from everything you want, from golf ads to porn to games to shoes to whatever it is that you want. And the advertisement network would actually require the publisher to integrate what's called a network SDK. And a network SDK is a library. It's a dependency. In mobile space, you have actually, I read a statistic that from Google in 2021, that 80% of an app is not written by the developer. It's written by other people, which is really fun. You're trusting 80% of random other people's work to be in an app that's supposed to be consumed by your customer, which is a very interesting thing. We live in a world where nobody wants to rewrite how to do video encoding every time. You just integrate a library. But that comes at a cost, and in our case, we have to integrate network SDKs to make money as publishers. Now let's talk about our fourth and last player, which is the attribution partner. The attribution partner is, okay, you made a game, you're a really cool game. You want to know if the advertisement network is cheating you, giving you Rolex traffic, really good installs, beautiful, beautiful users who will engage with your game, with your product, and they will be faithful users. Or they are bots, a curl request that mimics being an install or a click or an impression, because all of those are just HTTP requests, by the way. The attribution partner gives you a beautiful graph where you can see the total revenue, the spend, the active users, everything. You can track everything as an advertiser. You will have faith in this. Most of them, actually all of them from last time checked, have some sort of a fraud prevention suite, which means that you can actually integrate it to make sure that the traffic you're getting is real users. There's a big exclamation mark about this real users thing, which we're going to talk about in a bit. But that's what's advertised on the tin can. And that's our four players. Now let's intro my beautiful AI-generated anime picture of a game I call Bunny Fufu. I just gave an intro about you being an advertiser. You are a game developer. You're an amazing game developer. You actually just created this beautiful game. You use some AI images, you use some AI text. You told ChatGPT, please write me the beautiful game in Unity, and he gave you this. And you are now the advertiser. You go to an advertisement network and you tell them, I want everybody in the world to play Bunny Fufu. I want 100 million installs by end of today. On Google Play, on Amazon Store, on Apple, on everything. I want 100 million installs. Make it happen. The advertisement network will tell you, fuck yeah, let's do it. Me and you, brofest, let's do it. You pay 10K and you can do it. And then the advertisement network will talk to their publishers. They will use the real estate code that they have, the network SDK, and they will push your advertisements, whether it is a video, whether it's an ad bar, saying Bunny Fufu to all their publishers. Everybody should install Bunny Fufu. How do you track this as the developer of Bunny Fufu? You integrate an attribution partner who have beautiful. Can I go back? And they will give you slides like this. They will give you a dashboard like this where you can see all the metrics and all everything. And you're happy. You're seeing so much money coming from your game, your hard work. This is amazing. Now let's talk about the bad stuff. Advertiser, you pay the ad network. The ad network takes a cut. You also pay the attribution partner. Attribution partner will show you what the results that they get are. And the advertisement network will pay the publisher. Everybody depends on your money. Now, do they really care about you? Do they really, really care about you? Now, what's stopping the advertisement network from making 1 million requests, curl requests? That's it. Why do they need real users? Actually, let's take it a step further. What's stopping them from making 1 million requests and sending an event that says they just reached level 10 in your game? What's stopping them from doing that? And they just got money. They don't need to convert any real users. They don't need to convince them to do it. Let's talk about how this industry works and a few things that I've seen. So let's talk about some previous research in 2020. There's a company called Sneak, B-Sides Dublin. In 2021, I believe, Mr. Kirill Efimov, if I'm saying his name correct, amazing security researcher at a company called Sneak, and they discovered a network SDK that is doing extremely weird, convoluted stuff in the user's apps. And it's a network SDK. That means that it's a bunch of code installed in the app, and it's capable of doing things in the app space. And it's supposed to be capable of showing the advertisement to the users. but it's doing a little bit more than that. Now, I'm not going to spend too much time on this because Carol already gave a fantastic talk. Please check it out, besides Dublin. And they already made a lot of blog articles about it. But I'm just going to use a couple of slides just to illustrate how this thing happened and what happened after 2020, what happened after this big deal. Because this is a big deal. We got TechCrunch here, we got ZDNet, we got some Forbes talking about it, dark reading. It's a lot of stuff. So how this thing works. I redacted the pictures naturally because it's kind of stupid because the names are online, but still I'm redacted them because 2020 was a long time ago. So the idea behind the capability, the dark malicious capability that this network SDK had was that they were able to intercept. It wasn't on iOS primarily, but Android, they also had a few other weird stuff in it. It was both an Android and an iOS SDK. The iOS SDK specifically had the ability to intercept any URL that is open from that app. Anytime you make any HTTP requests, HTTPS request coming from that app, they're able to intercept it. Why is that important? What benefit do they get from that? Well, if there is multiple networks installed in that app, which is a regular practice for anybody trying to make money, you're not going to install one network. You want a network that's focused on golf, a network that's focused on gaming, and you want everybody to display ads in your game because you want more money as a publisher. Why would you restrict yourself to only a network that deals with, shoes or sneakers? You can integrate more. They were able to intercept any URL going out of the app and send it to their servers. And in the advertisement world, this basically allowed them to intercept clicks. Anytime you click on an advertisement, they know about it. Why is this an important thing? Because they know about it, they send it to their servers, and they send to the attribution partner the dashboard, the adjudicator that tells you that this network is giving you Rolex money and this network is giving you shit traffic. They send information to them telling them all those installs came from us. All those clicks came from us. And as I mentioned with the 6-second rule, if you are faster than your opponent, you will win. They made a lot of money out of this. And this was in the SDK. How did they do it was something interesting. Actually, it was mostly this block of code, which was really interesting. Obviously, it was an obfuscated sample. They used OLLVM. If anybody here knows, Mr. Duncan made a talk about LLVM for reverse engineers, but OLLVM is a pretty old obfuscator. I think it's 11 years now. Wasn't an incredibly hard obfuscated sample, but they used some obfuscation, and which is usually a red flag. Why would a network SDK displaying JavaScript and HTML need to use obfuscation? So that's usually a very big red flag. Now, they use a technique called method swizzling. We're not going to get into it for too long, but the idea behind it is that in Objective-C, anytime that you're trying to call a function, you do it through a messaging pattern. That's how Objective-C works. And this messaging pattern means you send a message string saying, please run this function, and you use a function called objc underscore message send. They basically intercepted this base 64 string, which will translate to UI application, open URL, and rewrote their own implementation for it. This is allowed in Objective-C space, by the way. It's called metaprogramming. Ruby has it too. I fucking hate Ruby, but they have it. So they were allowed to do something like this, which was interesting because Objective-C allows this. This is just part of how Objective-C works. Swift, to an extent, allows it, if I'm not mistaken, but I haven't looked too deeply into it. But I believe they still do something. But it really doesn't matter because there is a much more powerful technique we're going to see in a couple of slides. And they didn't get away with it. They got blocked from a couple of places and got put back because money, they're a huge network and stuff like that. You can read all about what happened, but that's 4 years ago. Who remembers? Let's talk about some interesting stuff, what happened after 2020, which was really fun. Notoriously, other network SDKs got inspired to do something even more cunning and hawkish than with these guys. And we're going to check it out right now. So, let's check Exhibit A, remote code execution through JavaScript. I love the word RCE very much, and it's usually a beautiful word. Makes everybody's eyes sparkle. It's as good of a word as when you say plain text passwords. It's just... mwah. So, RCE, let's talk a little bit about what's a web view. A web view, if some of you who don't know, it's basically an embedded browser. You have HTML, CSS, and JavaScript web technologies, and you can embed them in a mobile app, which saves a lot of time and space, because most of the time web is older than mobile, and you've already maybe had some stuff on web, you have some JavaScript stuff, you can reuse them in your mobile application. And a web view, at least that's the term in Android, which I'm going to use for both platforms, allows you to basically, it's just a window that allows you to render this information. And all mobile ads, in essence, are HTML, CSS, and JavaScript. They're web technologies. They're nothing more. There's no native connections. There's no native functions in there. The network SDK kits the HTML, which is big. Like 20 kilobytes worth of an advertisement. They don't just display an image. They do a lot of things. And and this is not even talking about the streaming. They do encoding. They control volume. They connect with sensors to see if you can do a gyroscope when you play an interstitial video game or something on the toilet while you're sitting taking a crap and playing the video game. They do a lot of stuff. They stream 1080p videos. They listen to touch events. They do a lot of things. And all of this is JavaScript, CSS, and HTML. That's not even talking about the resources that they're using, the images, the videos, and the audio files that they include. This is just text. It's a lot. So this was just an example of running a random app in like 10 minutes, and they just downloaded all this HTML for me to render and use. And we're going to talk about how the RCE works through that. So, yeah, this can never go wrong. You can control sensors through JavaScript. Yay! Okay, so let's talk about this beautiful thing. This was a very interesting find when I found it. So inside the Network SDK, there's some JavaScript bridge code. So the Network SDK is here. The JavaScript that they get from their servers is here. And there's some bridge code in here that understands the stuff that JavaScript understands the stuff that the advertisement needs to do, and it executes it in the app. This is just how JavaScript, and this is just how the native communication between JavaScript and native code works. All of this is in the Network SDK. And there is this beautiful method called call method. It's in JavaScript, and it specifies a URI scheme. A URI scheme that starts with MV colon / and then it includes something called, by the way, this was heavily obfuscated. I used the tool called Illuminate.js to be able to deobfuscate it. It's pretty good. I'm not a JS person, so that was actually a very easy thing for me to do, which is very good. It has method and parameters, and they include everything together like this, and then to do something. The advertisement can call this. The advertisement, if you have an advertisement that just has any URL scheme that starts with MV colon / and some stuff, it will do something. What does it do? Let's check it out. So this is the native code in the Objective-C in the Network SDK. This is the decompiled version, so you're going to see extremely ugly code in here. This is decompiled, my apologies. And the MV colon / is being handled by this function called process XXX request. And if you see in here, it just does some processing, blah, 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 and then it calls this beautiful method called JS call native with method name. There is no I. That's why I did the intonation. So what does this JS call native with method name does? Exactly as you expect. Call any function in the app. No restriction. None. You can call any function in the app through serving a JavaScript ad that starts with MV colon / and you specify the name of the function that you want to call. Nothing to do with the Network SDK. You can call any function in the app. Anything. Get IBAN number. Send $10,000 underscore to that person. Whatever it is that you want. And this is a simple blob that I just created, and it works. And if you just specify their own custom base64 encoding, they don't use the same base64 that you expect that they're using. It's obfuscation. My app.ui controller, this is something that I've written. If you serve this through a JavaScript ad, you will invoke that function beautifully. All you needed is just like, what? How many lines is this? Like 3, 6, 7 lines with formatting to run an RCE, to actually run code through JavaScript. It was beautiful. And this is still live, most probably in 90% of your phones. So, but how do they know which function to call? Yes, they can reverse the app. They can hire a person like one of you reversing the app, the target app that they're really interested in attacking. But they had an easier method. At least that's one of the methods that I've seen. They had a method to get the class hierarchy. They get every single method in the app that can be called, put it into a nice string, and send it to themselves. How do I know this? Because they're using those beautiful two functions, NSString from class and the extremely weird class _ get superclass. They call this iteratively through this while loop, and they basically collect every single function that is in the app that can be called through Objective-C, and they send it to themselves. And through that, they will be able to know which function that you would want to know. Obviously, this is interesting, but when you have a network SDK that's supposed to serve JavaScript and CSS, HTML, and you see that they have RCE and debugger capabilities, you start getting a little bit scared. There are some stuff that you see in the wild that just doesn't make any sense, and I believe obfuscation is the first sign that when you see obfuscated code, you usually don't think of them as defenders trying to defend their castle, but malwares trying to hide from reversers. That's at least my first thought. So that's Exhibit A. Now let's talk about Exhibit B. I have this and one more, and then I thank you so much for your attention. So symbol remapping. So this function, C code, not great C code, but it's C code, and it does something very simple. It just opens up a file, which is taken as a CLI argument. Actually, if I believe this was a mistake, it should be argv1. Argv0 will just point to the current executing bash script, doesn't matter. So simple C program that reads the first 4 bytes of a file and print them to the screen. Super easy program. Now there are 4 library methods, 4 libc methods. There is open, printf, read, and close. And my question to you right now, and please answer, can you redefine what those functions do in runtime? Anybody? Yes? Yes? Is this possible? I got a couple of yes, couple of nods. You can. Totally. Beautifully. Because we can do everything. Because mprotect lets us rewrite mapped memory pages, and you can do anything that you want. You can make those things run bunny foo printf 1,000,000 times, however it is that you want. Advertisement for our product. So this is how you would do redefining of the symbols of those libc functions. This is just one way of doing it, which is you call a function called rebind symbols from a library we'll check in a second, and you basically put your own implementation. There's many other ways that you can do it. You can do an LD preload trick, if anybody knows that name, where you basically put in your own implementation of libc. You can do anything. You can do a lot of stuff. It's really fun. It's actually really fun to play with runtime hooking. And the library that is really good at doing this is called Facebook Fishhook. Pretty fucking old library, and it's got like 10K stars, and it's basically a simple header file that you include, and you're able to call all this stuff. And it's really interesting because it deals specifically with macho binaries, with Mac OS and iOS binaries specifically. And it's really good at, basically uses mprotect and a couple of friends to rewrite the auth const and data const sections, which is where the symbols for libc would be located. And you can rewrite them to do anything that you want in runtime. In runtime. No Frida, no execution, nothing. You just put this crap here and you just do this, and it's just really fun. And like, obviously no network SDK would ever find the need to rewrite libc functions, right? That doesn't exist. Why would a network SDK displaying JavaScript do? Yes, they do. Yes, they do. It looks like this. They stole the an unmerged PR from Facebook Fishhook, put it into their SDK. Obviously, they didn't respect licensing, because why would you? It was GPL licensed, by the way. And they put it in here, and you can see the mprotect calls. This is the same fucking blob that is existing in Facebook Fishhook. That's the same thing. They can do memory remapping. Well, what does that mean? What does memory remapping mean? What does symbol remapping mean? It means that they can remap what any function, core function, forget about Objective-C messaging pattern, any libc function, they can remap it. Now imagine how beautiful is that? You can rewrite open calls, close calls, printf. You can rewrite OBGC message send, which means you have access to everything Objective-C will give you. If you're running an app on Swift, you have access to the functions for Swift, and you can remap what those do. do something, you can say easily, execute the function, but how about you send me a little signal to tell me that this function was executed? And very simple, very easy. Actually, there wasn't so much time in the talk to include this, but there was one of the network SDKs I found, they had two things, really interesting stuff. This is just, there is no slides for this, but I just want to mention it. They had their own HTTP stack. So in Android, if you use HTTP, you're going to use the OK HTTP stack. And they had their own TCP socket, encrypted TCP sockets implementation. So they basically had userland TCP talking through that is all in an SDK, in a Java SDK, talking to their own servers. And they had an HTTP stack that didn't respect environment variables for injecting your own certificates. So it doesn't allow man-in-the-middle attacks unless you've actually looked into it. It's a network SDK that you can't hook any man-in-the-middle attacks to, and they use their own TCP stack. It's beautiful. It's really nice. That means that you effectively, with some obfuscation, they can send any traffic they want from the app without you as an analyst knowing about it. Because honestly, mobile reverse engineering is not old. It's new. And most of the tools are written open source by people doing it as their side job. It's not as sophisticated as Windows reverse engineering. It takes time for people to learn this stuff. So they got away with it. They got away with it very easily. So that was interesting. So in the case of our network SDK with the RCE capabilities, they had RCE capabilities that they can dump every single method in the app, however they want, through a JavaScript add. And they were able to remap any function that they want through calling this function. And this is, again, meant for a network SDK meant to display images, videos. Play a 5-second video for you to engage with it and press a button, and that's it. It was really bizarre when you see that this stuff, extremely sophisticated tech, low-level shit is used in this context. Is beautiful. Now let's talk about the last thing on this. Going to be quick, actually. I do have time. I got like 15 minutes left. Now we have an obfuscation race. Now we talked about network SDKs doing the funky twice. RCE one time, and we talk about symbol remapping. Now let's talk about what you would call the defenders in this space. So who are the defenders in this space that we anointed as the adjudicators that understand and try to help and prevent bad things from happening to the advertisers? The attribution partners. They are the platforms that try to support and help and make sure that everything is clean and you as an advertiser see real good data. You don't see bot data. You don't see emulator data. You see real users that like your game and want to play with it. That's what we want. Those are the attribution partners. Now, this is MITM proxy. It's an intercepted request from one of the attribution partners. And the idea behind it is that this is what you would call an install request, which is a term known in the industry that when your app first launches, you just installed the app. You open the app. That app would send an install request, and that install request will send to the attribution partner, informing them an install just occurred. And it will tell it with a few device information. Like the advertiser would want to know, for example, what's your device, Android, iOS, what's your build version, device width, height, so that they can optimize their campaigns for you. Language, locale, a few other legal device information. All of this is pretty good. And this is how it looks like. And obviously this is obfuscated, encrypted, encoded, pick your word. We don't know what it is. But obviously it's not JSON. And we don't know that yet. It's what you would call obfuscated. We don't know what's happening with it. We need to analyze it a little bit. As I said here, it helps publishers and advertisers understand their customer base. And it also provides payouts. How does the advertisement network know that a user has just installed that we just got a new user who installed the app? Through a call request. Through a call request that will include a token that will say, there's this publisher, they installed your app, they're amazing publisher, we love them, and the user is going to engage forever and ever. It's amazing. And this is how they get their payout. To repeat, they get their payout through a call request, or an HTTP request, which is very interesting. Now, you can see it's obfuscated to deter hackers from making a quick payout. Obviously, as an attacker, I don't want to give you a playbook, but you can, for example, run a curl request. You can make yourself into a publisher and say, I gave this advertiser 1 million installs. And you basically just ran 1 million times curl request. And that is possible. Obviously, each attribution partner has their own fraud prevention suite, yada, 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 but we're looking at this guy right now. And most importantly, how good is their obfuscation? Because there is a pretty controversial feel about security through obscurity, and it depends about how you decide to tackle it. In my opinion, it is really hard to reverse a well-obfuscated binary. It's really goddamn hard. It's not fun. It requires a very high level of neuroticism, I would say, and I don't subscribe to that, and it's just really hard. So what the fucks per seconds increase from 0 to hero, so it doesn't make me happy. So reversing an obfuscated binary is just not fun, especially when it's obfuscated with like virtualization, or really like you forked your own LLVM and started doing some funky stuff with it. It's not fun. But how good is their obfuscation? Here is a decompiled AES encryption function, AES cipher, that they used. And as you can see, they use the ultra-powerful 16-byte constant zero vector as their IV. You might call it as the salt. It is constant, never changing, never has changed in any version of the SDK. And the key is the name of the app. Amazing. And again, did make a disclaimer that I'm not kicking anybody in the balls, because this is not my intention in here. But it's also my intention to point out this stuff so that, well, we can learn, push it forward, try to maybe figure out something better. And here's a hashing function from another attribution SDK. Now, this hashing function is supposed to make sure that all requests are tamper-proof. This is something that the attacker shouldn't know, shouldn't have access to. It's a SHA-1 of the first 7 characters of the app ID, which is the name of the app, the how much memory do you have in your hardware, HW, and the timestamp. And if you SHA-1 that together, that's supposed to be an ultra tamper-proof watermark that will deter any attacker from ever replicating these requests and not being able to understand anything. Obviously, I'm being sarcastic. This is trash. But the thing is, it's not easy to come up with a system that is tamper-proof. It's really not. And this might be a little bit not the best approach, but honestly, it's not easy being a defender at all. As I mentioned in here, it's like sending the key with the locked box. But as I mentioned maybe 4 times right now, defenders spend a lot of time doing things that has nothing to do with this. And a joker with a stupid computer like me coming and telling them, kicking this, and it's like, break it, fix your shit, is not going to be super helpful, because they have other priorities. They need to run shit on CI. An attribution SDK is supposed to run on every single hardware successfully, do scheduling. They have to attend meetings to take care of integrating other partners that have nothing to do with security, while the attackers have one job. It's a really, really hard arms race, and to be honest, the odds are stacked. And it's not my purpose right now to give a solution, because, well, a complicated problem requires a complicated solution. But I just wanted to showcase how this works right now, how most of the industry works right now, with extremely few exceptions. And I come to the conclusion, and the conclusion is going to be basically talking about Miss Michelle Bonan, if I'm saying her name right, which I actually like the new movie. I really liked it. And the advertisement industry, the mobile ad space, reminds me a little bit of this. It's a bit like walking through Alice in Wonderland. It's psychedelic. It's weird. Network SDKs supposed to display HTML are doing symbol remapping for libc functions, and JavaScript ads that's supposed to engage with users are doing RCE capabilities with debugger capabilities. And what else? We have attribution partners trying to defend with poor man's techniques relating to hashing and package names used as keys for AES ciphers with 0 null vector 16 bytes. It feels weird. And to be honest, I don't think I've said the word user, you, ever in this talk, because you don't matter at all. None of you, nobody cares about you. It's all about getting the advertiser's money, running on your devices, doing things that you most probably don't know about, unbeknownst to you. And that's how it goes. And to be honest, as I said, all of those people have jobs. They have 9 to 5s. They're doing their best to try to do things while attackers try to basically break stuff. And again, they break it for 3 hours, and they have to implement a solution to make shit automated and work. Like the network SDKs people, yeah, they're doing dark stuff, but honestly, if they paid, I can point a finger in here, but if they paid enough money to someone, would you do it? Don't answer that question, but it's a gray world. It's really weird. And, it just reminds me of a really fun quote in here, which is like when Alice met the Red Queen, which is really portrayed nicely in the movie, when she met the Red Queen, and she said, it's like, oh, in our country, you generally get somewhere if you run very fast. And then the Red Queen was like, oh, it's a really slow country. Where I come from, you need to do all the running just to stay in the same place, which is really fun, because I believe the status quo now is that everybody is enjoying all of this. And there's a lot more dark stuff, and they're enjoying it. And what's the solution? As I said, I'm not here to talk about solutions. I'm just here to show you a few things. Thank you so much. This is my talk. I really appreciate your attention. I think I finished in good time, right?
So do we have any questions in the audience?
You can always find me outside. I'm going to be in the after party. Ideally getting stoned. Is it legal in Prague? No? Okay, I'm not. Ignore. Am I still being recorded? Holy crap. Oh. Thank you so much.